Hey guys, it's Vince. Today in this video we are going to be discussing my new Master Edition enclosure, and this particular unit right here was specifically built for a client that requested certain features. And when I say certain features, he realistically wanted virtually all features the G540 supports, and I've been getting a lot of questions on how this enclosure can support all of those features. When I say virtually all those features, the only thing he didn't request is an additional relay. The G540 does support two outputs. This unit is using one of those outputs to control a spindle relay, and that's of course the cyclist spindle on and off. What you have here with the graphics, again, very extensive. I've already covered the GX16 female 6-pin interface cable. That single cable will plug into his GX16 port right here, which is the 6-pin connector, which the Master Edition does include, with the dust cover, of course. And that will allow him to not only manipulate the speed of the spindle in Mach 3, but also allow him to cycle on and off the spindle with one cable. Okay, you can see here all the detail in the graphics, because I get a lot of questions about this. You've got the GX16 connector panel mount that's actually broken out here with all the graphics so that he knows exactly what wires go to what internally in the chassis. And then the one beneath it also breaks down the VFD interface cable. It also, on the top, explains that the relay settings for Mach 3 go to ports and pins, go to output number 1, put a check port in port 1, pin 17, and that way his relay will function. And you can even see the detail of the VFD itself. Over here, we had to install all of the switches. He required three switch ports, I should say, wired. And then on top of those 3 switch ports, he also required input 4, which is a 4th switch port, but in his case, he'll be utilizing a touch plate. You can see here I integrated all Mach 3 settings on here for him for each switch, for each input. So he's set there along with all of the wiring again. Again, guys, when I tell you guys that each system is done custom, this work, depending on what you order, is going to really break down a lot of time savings if you guys are in the field. As long as you pay attention to what's on the box, you really can't go wrong. I mean, that's what I'm trying to do, is take the guesswork out as if I'm more or less there with you. So again, you can see here the extensiveness of what this system offers. We're going to go inside now, because many of you have not seen a system set up this way. So you can see exactly what we've got. We've got our relay decal right here, so he can actually have all of his diagrams here so he knows how to service it. Over here again, I also transpired and put the GX16 panel mount again inside the box, because it's a pain if you're working on it to look at the rear and then look inside. It's better to just have a separate graphic for that, as well as the inputs, the same decal allocated to the G540. Now you'll notice it's going in a horizontal direction, and the reason I did that is so that it matches the ports and the location of the port chronologically on the drive. If I was to spin this decal around and he was to interpret it, it could be interpreted incorrectly and we could have some serious issues. The other thing I wanted to point out before we get into a little more detail is here's a new graphic I just made, and I will be including this now with all G540s because I think it just saves a bunch of time. And this shows exactly how our actual drive is allocated with its terminal block. So now there's no more guessing. You know exactly where your inputs are, where your outputs are, what number you're working with. All you have to do is count the actual block terminals, and this chronologically correlates directly to it. So as long as you're looking at the drive from the rear, you know exactly where you're at and what you're hooking up. Okay? Now as we come in for more detail, you can see here we've got the V-negative terminal splitter on our power supply connected, all ring terminals set up. Again, all solder connections are done. Then beneath that, you've got your ground bar. And I get asked a lot of questions, and it's interesting. I get a lot of people that ask me, how is the ground bus connected with spacers underneath? Well, of course, you're going to have screws that come up. You can see the screw heads right here. When the screws are making conduction with the chassis and come up here to the brass thumb screws, they lock down the brass bar, and that once again grounds it. Over here, you can't see it, but inside these spacers is a gap. this screw that's mounted all the way through this bar is not making contact with the chassis, therefore it separates the two. You can see how height differential, the reason I went so high is naturally you can pass the wires underneath, pass these on top, and you got a nice clean setup like you see there. Other thing to note, you can see here, ferrites are installed right here on the relay signal cable. You also, I'm going to turn this around so you can see it, on the inside of the system. If you look over here, you can see ferrites installed on each of his inputs to control his switches. See how small these leads are? The white leads are all of that. Matter of fact, all of the wiring there that you see wired for the inputs, you can see how small it is. Everything is silicone based. And again, keeping the leads these short along with the ferrites naturally for passive shielding allows for, once again, the shortest signal interception, and therefore we don't have to worry as much about EMI. Always keep your leads as short as possible. You can see how they come into the drive right here. I mean, it's a very, very short jump. Max lead is maybe 5 inches. So again, real simple setup. You can see how everything is basically nice and tidy, because I get a lot of questions. How do you do this? How do you set everything up? Again, the relay is mounted toollessly, nothing fancy there. Everything here has been in other systems you've seen. But as far as the hookup of the V-negative terminal splitter and the ground bus, now you see what a full system basically looks like loaded. This is it. The only other feature he could add is another relay. He could add it on the opposite side. He could add it over here. Again, we have our terminal bus, our 48 volt terminal splitter labeled, as well as our ground bus, so he knows exactly what he's working on there. There's no surprises here. The other interesting thing to see, you guys are going to probably watch the other video that I did on how the back plate is wired, but you can see the GX16 wired here. And again, we have to use 20 gauge leads. This is 20 gauge silicone leads because, again, the terminals on a GX16 6-pin is much smaller. So pay close attention to that. If you are going to do something similar with your own chassis with the VFD interface and use a 6-pin connector, you want to make sure that you're using 20 gauge leads, because if you go larger than that, you're not going to be able to fit it. It'll be very difficult. Okay, and that's why you'll notice here he's got 20 gauge leads coming out from the relay going into the GX16, and the reason we did that as well is because, of course, right here we're connecting on this end with a GX16 6-pin, so there's no way I could use larger leads. But it's nothing critical, because the relay itself is set up in a dry contact configuration. And for those not familiar with that term, that simply means the relay is closing the completed circuit. It's not supplying any voltage or amperage. It's not doing anything other than, once again, closing that circuit so we can cycle the spindle on and off. So again, you can see what we've got here. Very, very simple. This ground right here, because I've gotten a lot of questions, is this. You can see the GX16, that's for a shield drain. So the guys that have watched the other video of the back plate being wired, I've got a giant ferrite in here as well. I recommend you go over to that. I don't think she'll be able to shoot that. It's underneath. But I'll try to turn the chassis so you can see it. But right here, you can see that ground coming in, and boom, as soon as he plugs the cable in, that's where we have our grounding done, and that grounds out his cable and he's set. So his double shield is all good. See if she can shoot the ferrite in there. I'll arc it up. And you can see right there is our ferrite that is now used around all of our GX16 6-pin coming from our VFD interface cable, and that filters out all of his signals going to his relay. So when he plugs that cable in, all of these signals are now filtered. You can see a lot of passive filtration, so we keep the box as neat as possible. And again, keep it simple, guys. The more you want to hook up, the more guys want to use shielded cable when they can afford to do ferrites. Ferrites are very cheap. The big thing here is understanding what ferrites you require. Please don't contact me, and I'm getting a lot of weird questions like, give me your supplier for ferrites, give me this and that. I mean, realistically, they're very cheap. I've done my homework, and therefore I don't think I'm asking too much. If you guys need them, message me and I will sell them to you. They're not that expensive. Overall here, you can see the work has been done. This is made so that the client will be turnkey virtually out of the box once he sets up Mach 3. And again, it justifies the price that, once again, these enclosures cost, because there is a lot of work done here, especially when you factor in all of the machining is already done. Okay, so when you buy the Master Edition enclosure, of course, it doesn't come with all the electronics, but it does come with all your machining done, GX16s. And again, based on each client's preference and each client's specific use, that's where we'll have different hookup configurations and graphic configurations. Because again, these graphics essentially are like somebody being there and explaining to you what needs to be done. No one does this. There is no one that does it because it's very time consuming. And again, it takes a lot of equipment. I'm not going to lie to you. I have a plotter, I have a special printer, I have to deal with different vinyl in-house, lots and lots of money invested to do all of this in-house. It's not that it's impossible, but it's not always practical for smaller businesses. So again, this makes, I know, the client's job a lot easier. I can't tell you how many past clients of mine love it, because if they do have to work on anything, it's all right there and you can see the detail. And again, inside the box as well. I try to keep it as simple as possible so you guys are aware of exactly what you're doing. Okay, so again, I hope this video has been helpful. Now you've gotten to see a really in-depth look at one of the most advanced G540 setups you'll see. I've got more videos coming. I've got a lot of stuff I'm working on. I've been building a lot of cables lately. That seems to be the hot ticket item right now, is a lot of cables. Again, I'm planning on doing more videos on systems because I'm still getting a lot of requests for different things. If you guys do have questions, and I know looking at a video is great, but questions always arise, please message me direct at storm2313@gmail.com, or you can contact me through my eBay store, eDealers Direct. You'll see the video, the link in the description. Just go down to the video description, and all that contact information is there. To all of my subscribers, I love you guys, and if you guys do find the video interesting, please like and subscribe. The channel is growing, and I really do appreciate it. Thank you all for your support. Take care.